Hi guys, welcome to our first online lecture. My name is Alice and we have seen each other in our online tutorials. So today we are going to have the lecture 3, which is based on the course note N3. If you still remember, last week we have looked at linear and quadratic functions. And we have also talked about what you need to do when you're asked to sketch a graph. So in this lecture, we are going to look at a bit further into polynomial functions with the main focus on cubic function. So based on the definition, a polynomial is the finite sum of terms in which the power of any variable in any term can only be a positive integer. So here I have given you a general expression, an example of a polynomial, which is in the blue box. So you should have already seen this if you have read the course note. So here an minus 1 all the way up to a0, they represent the coefficients in each terms. They are real numbers, alright? They're real numbers. So one important condition here is that an, which is the leading coefficient, cannot be 0. I know it all sounds a bit complicated, but what this definition is saying is that polynomials should look like this. So here I have provided 4 more examples to show what polynomials could look like. Some polynomials have several terms and some of them have just one term. In fact, we have a naming system to call each of them when they have different numbers of terms. So for example, if an expression has just one term, we call it a monomial. If it has 2 terms, we call it a binomial. When it has 3 terms, we call it a trinomial. And then for anything above 4, we just call it the number plus term polynomial. For example, if it has 4 terms, we can call it a 4-term polynomial. So the naming system is actually quite straightforward. In this slide, we are going to look at the degree of a polynomial. For a polynomial in which there is only one variable, the highest power that has a non-zero coefficient is called the degree of the polynomial. So if we look at the second row of the table, we've got 3x minus 5, which is a linear expression. The next one, we've got a quadratic, and the last one is a cubic. If we look at the first example, because it is just a number, so we call this a constant. In fact, we can see the first example as 7 times x to the power of 0. And because 0 is the highest power, so the degree of this polynomial is 0, and the leading coefficient is 7. And similarly for the next example, the linear expression, because the leading term is 3x, which is the same as 3x to the power of 1, so the degree here is 1, and the leading coefficient is 3. For the quadratic expression, the leading term now is 5x squared, so the degree for this polynomial is 2, and the leading coefficient is 5. And the thing that you need to notice here is when we read x squared, there is actually a d at the end of the word squared, so it's squared. For the cubic expression, now the leading term is 4x cubed, so the degree is 3 and the leading coefficient is 4. Again, something that you need to pay attention here is when we read x cubed, there is a d in the word cube, so it's cubed.